We now enter the bulk of this module, and that's going to be triangle congruency and proofs. We're going to focus first on the side angle side. Now, this right here is a side angle side theorem, which we'll abbreviate as SAS. So we have two sides and the included angle of one triangle. And so what that looks like is here's a side, here's a different side, and where these two sides meet, they meet at this corner right here. So this angle right here is called the included angle. And those happen to match to corresponding parts of this congruent triangle. So that means this side will match this side, BC will match YZ, and they have the same included angle. Remember, having the single dashes means that these sides correspond to each other. And so we show the pairing off, right? You have these sides are congruent. So there's a pair of sides. And then there's another pair of sides that are congruent. And the angle in between those two sides, so the angle that's shared, that's common, right? So these two sides, AB and BC, for example, they don't meet at angle A and they don't meet at angle C. They meet at angle B. And same thing over here, XY and YZ, they meet at angle Y. So then if I have the included angle, then we, by the side angle side theorem, the triangles are congruent. Now there's a big deal about this that we're going to hit up later on, but if we can prove they're congruent, then everything about them is congruent. We'll talk more about that later. So let's spend some time identifying included angles. So for part A, JK, here's JK, and KL, here's KL. And where do those two meet? At what angle? Well, we can't say angle K, because angle K could also be this big one, or it could be the small one right here. So to appropriately label this, we could either call it angle JKL, or if you want to label it angle LKJ. And I would refer you to the angles video from last semester to help you know how to label these correctly. Part B, LP and KL. They happen to meet right here, but we can't say angle L. So we'll go ahead and say PLK. We could also say KLP. Remember that when we do this, that the vertex has to be in the middle of the two. And finally, JL and JK. Where do those meet? They meet right here. And there's no confusion this time. So we could actually say for part C that the included angle is going to be angle J. Now, if you want to be really technical, you could say angle KJL as well, or you could say angle LJK. But for this one, we could say angle J and get away with it. Now remember, side angle side, there's a reason why it's spelled this way and not spelled the other ways, right? It's because the angle is in the middle of the two sides. It's the included angle. A quick warning that from this point forward, you might feel lost if you're not comfortable with previous geometry topics. For example, the reflexive property, right angles, vertical angles, parallel lines. You might want to review those things. So if we want to decide for problem 2 if we can use SAS, in other words, we need to find a pair of sides and another pair of sides, and then the angle in between those sides, the included angle. If we look at A, for example, and you might have a hard time seeing what's going on here, but if you take this triangle right here and separate it from this triangle right here, we get this drawing. And so if it helps you to separate it, that's cool. But I'm going to refer to the original drawing because it's beneficial. We see that LM is congruent to TN. And I'm going to try to keep this in the order. So if I'm going from top to bottom on this one, I'm going to go from top to bottom on this one. Now, angle M is a right angle. Angle N is a right angle. All right angles equal 90 degrees. That means these two angles are congruent to each other. So check it. We have a side. We have an angle. Do we have another side? Might I suggest to you that for this triangle right here, MN is that length. For this triangle right here, NM is that same length. If you're wondering why I wrote them backwards, it's because on this triangle, I went from this right angle to the other corner, MN. On this triangle, I went from this right angle to the other corner. Now these happen to be the same length because they're on top of each other. These are congruent, and they're congruent, by the way, because of the reflexive property. So if you go back to your properties, reflexive property is the one we're using here to get this third side. It wasn't labeled, but we understand that it is the same side. Okay, so we have side angle side. So I'm going to mark this as a double. So notice that I have the included angle here and I have the included angle here. So the answer is yes, I could prove this by the SAS theorem. Now, if you think about that, we didn't really do any math at all, period. We just looked at the picture, looked at the shapes, saw what was given, used prior knowledge, and then we were able to line up, okay, we have the side, we have the angle, we have the side, and this pretty much could be an entire proof if we wanted to. So the answer to A is yes. Part B, well, they gave us that TR is congruent to UW. And again, let's keep that order, right? If I'm going from top to bottom or left to right. I have TS is congruent to UV. That's an S, sorry. Great, so I have a side. I have a side. For me to do SAS, I need to have the angle between these two, the angle that is shared by these two. So if I look, for example, at RT or TR, is this right here. And if I look at if I look at TS, it's this right here. They meet right here. Do I have this angle? I do not. I have this angle instead. This angle that they gave me is not the included angle. So I have the two sides and I have another angle. So you're all trying to spell either this or this, but those things don't really exist. Okay? At least in the geometry sense. In this case, we're focusing solely on side angle side. We need to have the included angle shared by those two sides. We don't have that, so the answer to B is no, we can't do this. Part C is a lovely one. Okay, so they gave us actually, all of them are congruent to each other. Okay, so AC is congruent to, I'm going to do DC. And then BC is congruent to EC. That's a side. That's a side. Gee, they didn't give us the angles. They didn't give us any angles. However, these are vertical angles. Oh, snap. Yep, vertical angles from back in the day. Vertical angles are congruent. And these happen to be the included angle, right? So if I have this and I have this, well, where did they meet? They meet right here. Or this one, and they meet right here. So they gave us, we found the included angle. So this is the actual angle between the two sides. So the answer to this is yes. Now, if you need to pause this and go back and replay this or rethink it, you're highly encouraged to do so. Because this kind of mentality, notice how much thinking we did and no computation whatsoever. There are no numbers, no equations to set up. It's what do you know, what do you see, what could we do? All right, let's do a proof. So check it. We got this A, B, C, and this X, Y, Z. And note that this is labeled for us. So you're looking at it and it might be making you confused because you're not seeing it in the right order. You're free to always redraw these. So if you're having struggles with this, erase the one that is ugly for you and go ahead and redraw it in the same orientation as the other one. So if that helps, feel free to do that. Otherwise, rotate your paper. So let's do a standard 2-column proof. Remember, the first step we generally write down what's given to us. And we identify that based on what they gave us, this side and this side happen to meet at this angle, which is given to us congruently. And so this is already done for us. By what reason? By the SAS theorem, the side angle side theorem. And we're done with that proof. Take a moment to summarize. Why does the order of the letters in SAS matter?